All right, we are live. We are live. Try not to do that right in the mic. Man, life has been busy. Life has been crazy chaotic. Hope everybody's doing okay. Welcome back to Chiller Questions Answered series, where we do a live stream like this and we just talk chillers. I'm here to answer your questions. We do have a question queued up already. We're going to talk about expansion tanks for a minute, but just kind of giving a touch base, coming back in with everybody, and then feel free to get your comments in the chat. With me going on, call it paternity leave. So we just had our newborn. It was June 5th, and he was several weeks earlier than expected. All of my kids have come about 41 weeks-ish, and he decided to do 37. So technically, 37 is still okay. They're not worried about 37. At least that's what I'm told. But we were not prepared for it because the other three, that makes four for me, the other three did not come that early at all. So we had the mindset of we had time to work on things. Either way, if the stream does look a little different or if anything kind of is changed, I am trying a little bit of a different setup. I've recently moved to a Linux-based operating system instead of Windows. I like it a lot, but it's taken some tweaking and adjustments, and if you're familiar with Linux whatsoever, you'll have an appreciation for what I'm talking about. But so far it's actually going pretty well. I've actually even switched to a green screen style instead of using that weird GPU AI thing that was just not very stable, but it did the job. But I figured out the green screen thing now, so I didn't think about it though. I wore kind of a green shirt. Oh yeah, so Mechanical Environments, these are pretty cool people. I'd recommend you go check them out on like Instagram and whatnot. But they have a green logo, and I didn't think about that when I put that shirt on this morning. So got things I gotta get in the swing of with having a green screen. So yeah, life is busy. Kids, we had that flood come through last week in Kerr County. So I was actually there on Saturday helping do recovery efforts with the fire department. So I was assigned to a task force to go down there and help. So that was fun. Not really, but it just, yeah, that was some pretty serious devastation. Actually seeing where the floods hit first. Anyway, we're not here to talk about all that. We're here to talk chillers on a happy note. So like I said, if you want to get your questions in, feel free to go ahead and do that. I will be able to focus on some of the comment questions today more than I typically would be able to right at the beginning. So we're just going to kind of get back into the swing of everything. If anybody has any trouble, feel free to let me know in the comments in terms of everything's coming through. I'm clear on the audio, yada yada. Anyway, getting back into this. Okay. Could you touch on expansion tanks and chilled water systems? Key points would be its location in the system first and foremost. Okay, so let's come over to our whiteboard here and let's draw this up a little bit. So an expansion tank, let's just cover real quickly just what that is. So this is it's a cylinder that'll have a pressure tap. Usually, let's see, it could come in on the top or bottom. It'll just be a tap on the end that the piping will connect to. And inside of here is a bladder. Okay, there's this big bladder that will fill with water. And in addition to that, we'll have a little air chuck port like you'd see on a car or a bike tire over here on the side. So this cavity around here will pressurize with air, and this bladder inside will fill with water. The whole point of this system is to help us maintain water pressure on the loop. So specifically, we'll have a pipe coming over, and if we have our pump assembly over here, so let's just say this is our pump, this is the pump inlet flange, we have our outlet flange with the pipe water going out. So we would end up connecting to this pipe here on the pump. Okay, so this is the same place you would also have your makeup water and such connected as well. So what's going to happen is as the loop pressures would naturally fluctuate, which they will. So as water changes temperature in the loop, the pressure will increase or decrease with that change in temperature. And this could be something as simple as just we had a off cycle where we did a shutdown overnight. We come back on the next morning and we need to we're processing the loop down. Well, that whole process is going to cause a lot of pressure fluctuations due to the major temperature swings from the loop being not processed overnight to needing to get it processed the next morning. These bladder tanks help correct for that expansion, which is where that's where the expansion tank concept comes from. As that pressure increases on this loop, this tank or this bladder will be able to expand out, and it's going to push against the air pressure in the tank, in this cylinder. So as that's happening, we have some room to kind of breathe in and out on the loop without having the loop pressure as a whole expand in and out excessively. Now, in most plants, I see that they try to put these at the top of the loop. Sometimes that means if the whole plant and pump assembly are actually at the top of the loop, then the whole thing will just be up there together. It's one piece. And there's been some cases where I see that they'll put this at the top of the loop, but the plant and the pumps will be down at the bottom of the loop. So these are not always located with the loop, or I mean with the pumps. Sometimes they'll be separate at the top. Sometimes they may be down close to the pumps. So those are the two locations that I personally see these being implemented the most. Either the very top of the loop, or at the, I guess most of the time the pumps are at the bottom of the loop or the top. So it could be either or. The purpose of what they're doing and serving works the same either way. And one of the things that, and this tripped me up for a long time, is we want to set this tank pressure to what our loop pressure is desired to be. Okay, and we want to do that at the operating temperature. So if we have a loop that we expect to run a 45-degree supply water through, now if this was pushing through our chiller, for example, then this pump should be feeding into the chiller. So if we had a 10-degree design loop, which would mean at load, we would have roughly 55 degrees coming into here. Then that 55 gets pushed to the chiller, chiller turns it to 45, and then it comes back out to the rest of the building. So in that state, I would prefer to be in that 50s range right here. So if I was between, say, 53, at least 52, 53 on my incoming water, that would be close enough, in my opinion. You're within a couple of degrees to then set this tank pressure. And the reason for that is you want this tank calibrated to your operating conditions, and then allow the off cycle when it heats up to be able to expand out further from there if as needed. So that is just my personal preference, or I say it's my personal preference, and to my understanding that is the best way to go about it. That's the way I've been trained to do it, is more of what I'm trying to say. So yes, with the loop at operating temperatures, you will use just a regular air chuck gauge, and you will set this this tank pressure to that. They'll come preset. I've seen them like 12 psi or something. It's pretty common for these to come from the factory, which if this was at the top of the loop and the if your tank was at the top of the loop and you're running a normal loop, which I would say at the very top of the loop, your return line that goes back to your pumps at the very, very top, I would expect that to be roughly about 10, 12 psi, typically. So if that's where it's going, which a lot of the times that is the kind of preferred place for it to go, then that default pressure straight out of the box would be fine. But I have found that a lot of these, they don't get field calibrated. So they'll get put by the pumps, but the pumps are down several stories below, so they're not at the top of the loop, they're more towards the bottom. But they did not change the calibration on this. So basically, if you do not calibrate this pressure of this tank, and this should be something you check on a at least annual, if not quarterly basis when you're doing the maintenance, then you end up, once the loop is filled, this is going to be a higher pressure than that 12 psi all the time. So let's say we had a 3-story building, and let's say we had 7 stories per floor, and we were at the bottom of the loop with here. So 3 times 7, that's 21. Add about 10 psi, that's about 31. So I would expect about 30, 31 psi here at this pump inlet. So if this is set to the factory default of 12 psi, well, this has no purpose in the loop. Like, it's serving absolutely no purpose because it doesn't have enough counter pressure to actually act against that bladder at that point, which completely nullifies its effect. So it's important that we know where it's at in location, what the loop pressure is expected to be, and that this tank pressure is calibrated to that pressure. And to my understanding, like, there's no issue just putting standard air in here. I know some guys put nitrogen in there, which with their regular gauge hose. So you can go about that process however you wish. But that is the core concept of what a expansion tank is and where it would be, and then how you would go about calibrating that in the system. How much exact pressure is create? So yeah, that pressure is going to depend on just, again, where it's at in the loop and calibrating it to operating pressures. Okay, that's with your loop temperatures down where you want them to be. That's going to be kind of your default mode. Have the loop processed, and you'll have to calculate your feet of head weight from there to determine what your tank pressure should be based off your loop pressure. And I've heard some guys say you want your tank pressure slightly more than the loop pressure. I hear some say slightly less. I personally just kind of shoot for a median. If I'm looking for a 30 psi loop pressure where my tank is specifically, so that, again, your elevation changes that. So if I'm looking at 30 psi there where it's connected to the pipe, then I want to see 30 psi on my tank, give or take a couple of psi, okay? So it doesn't have to be absolutely perfect. Anyway, this is a really good question. Any other questions? I do have some. I've got plenty in the backlog I haven't been able to get to. But any other questions? Hope everybody's having a good start to your week. It's a crazy time of year. It's a very busy season for everybody. Very busy season. I know we've had a lot going on this side. Yeah. Okay. Like I said, if y'all have any questions, feel free to throw them in there. I'm going to move to the next one. I will be limited to about an hour compared to my normal 2 hours. So here in about 40 minutes-ish, I will be having to jump off. Got some appointments for the kiddos. But in the meantime, let's talk some chillers. Let's get this one in here. Paste. Okay. Ooh. All right. So, how frequently should you consider eddy current testing? My default is 5 years. So I just stick to a 5-year schedule unless there's reason to do it otherwise. So there are some reasons. If we have a specific condition in the plant, so there are some plants that just have a very call it more critical schedule. They stick to a more rigorous schedule. So we have to just kind of adhere to that, and they may want it done annually. So there are some facilities, they literally want an eddy current every single year. It's just their preference. A lot of times they may have very specific reasons as to why. I've seen some do the same thing just on a 2-year rotation. I know 3 to 5 years is kind of like the default answer by the industry. I just choose that 5-year if there's not a reason to do it sooner than that. Now, some other reasons you might want is if there was maybe a failure in the loop, or if you were coming in behind another company and you're taking over a property, it would be good your first year there. Let's go ahead, let's get a full baseline, let's eddy current this. Even if they say, well, the other company had recently had an eddy current done, it's still, I see it as a means of just kind of CYA. You really want to understand with the machine you're working with. It's not a mandatory for me. I'm just saying that it might be one good reason to do it, and I do recommend that. If you're worried something didn't go right with a recovery or a charging procedure, so either of those scenarios, or if you're worried that there could have been a freezing condition that formed or happened for any reason, like anything like that where you could have had a frozen water in those tubes and cause those tubes to expand out, those are all good reasons, in my opinion, to maybe do an eddy current prematurely before the 5-year mark. And I do the same for the condenser and the evaporator. So when we commit to doing an eddy current, I will open them both up and just do both heat exchangers at the same time on that 5-year rotation. Again, excluding external events. So another one that happened was really old plant. The pump strainers just disintegrated and came apart and turned into shrapnel down the piping, and that got into the chiller condensers and was just wrecking havoc. So that could be another opportunity where, yeah, you know what, let's go ahead, let's eddy current these and see what we find, because all those little shards of strainer running through that loop just become, that's all puncture points as it's bouncing around inside of those tubes flowing through there. And so really, really important that we try to catch that sooner than later. And that particular plant, they were very resistant because it was a very complicated situation, but we were having a lot of leak issues, major leak issues. And it was because those condensers were very heavily damaged by that strainer problem. Not to mention they also had some flow issues, which no figure they had flow issues. They had strainers get sent through their pumps, and their pumps were kind of struggling to survive. So it kind of became this whole self-feeding cycle of failure. Yeah. Why is the chiller humming? What is the reason? Yeah. See, I told you. Hey, these are great shirts. I love these shirts. Mechanical Environments. They're here. Y'all go check them out. I'm serious, guys. Really, really awesome people. Anyway, sorry. I saw a comment, got me off track there. So let me just cover real quick, if you're not comfortable with what an eddy current is. And these are kind of things I talk about in the certification course at chilleracademy.com. So like all this kind of topic is what I'm discussing in there, explaining what these things do and what my recommendations are, very similar to what I'm doing here. So an eddy current, basically, we have a probe, and you want to do this after you brush the tube. So you'll drain the barrels down, open the end bells up, or the water boxes, and then you will brush those tubes out, make sure everything's clean. You want to have as accurate of a test as possible, so you don't want to have anything in the way. And it's also good to know that if you have an obstruction in a pipe, before you send the probe down there, let's figure out if that obstruction is there. That way we know ahead of time, hey, this tube here, be careful when you're putting your probe through. So anyway, the eddy current itself it's just a little probe that sends out an electromagnetic field, and there's a oscilloscope type device that is monitoring that field for variation or interruptions. And so an eddy current certified technician monitors that as they're going down each tube. And when they see certain disruption patterns in the field, that can indicate to them, one, either a bulge, depending on the shape of the pattern, or it could indicate an actual hole. And the ones I've worked with, they've been able to tell the difference between the two. So, yeah, that's what that eddy current process is doing. Is that field that gets created indicates to them if there's damage, what kind of damage. Another could be just a thin wall. So one of the things that happens over time, especially if you have excessive GPM or just really harsh water conditions, you could thin the wall of the tubes out heavily. And so you can, in some spots, you could actually literally have these really just thin spots. So even if it's not cracked, even if it's not bulged, it could be very thin due to erosion. At that point, you still want to decommission that tube and put plugs in, because if it's already gotten that bad, it's probably only going to continue, and it's such a thin, weak point in the system, it's not worth the risk of having a system flood. Like, if you haven't flooded a chiller before, it's not fun. Like, it's not a process you want to go through. So those are kinds of things that you, like, the whole point is to not let that happen. That's why we have eddy current come in to begin with. We don't want that to happen, period. So just kind of some high level thoughts on eddy current, how it works, and when we want to, like, my recommendation on when to do it, and what are some exceptions that could happen to need to do it sooner. All right. Howdy, everybody. Hope everybody's doing okay. Feel free. Like I said, if anybody has any questions, you want to talk about anything, just go ahead and throw it in the chat, and we will discuss accordingly. Right now, I'm going through some of the backlog questions we had and covering those. How do you explain the difference between VGD? This is a fun question. We need to. That works. Okay. How do you explain the difference between VGD operation and VSD as it relates to part load? So, to separate the two real quick, your VGD is a variable geometry diffuser that is in the diffuser section coming out of the compressor. So let's look at that real quick. So if we have our inside of the compressor here, we have our back wall of the rotor housing, we have the front. This is your impeller sitting inside of here. Okay, that's going to come across, come down this back wall. Right in here is your diffuser. We'll have a VGD in some of these increasingly more modern designs, where there's this ring that will slide in and out based off of an actuator, and it will change the dynamic of this diffuser gap. Now, the whole point of this diffuser is to start to convert the kinetic energy that the impeller puts on the refrigerant and convert that over into a static pressure, a potential energy. Okay, so we're converting that kinetic into potential, which is what we read with our gauge pressure. So this is the whole aerodynamic aspect of a centrifugal. So this would be our VGD here. Okay, just so we're clear on what this is. Now, a VSD is just a drive. So a VSD is just a VFD, okay? AKA VFD. So York says VSD, variable speed drive, variable frequency drive. It's just York being York. So with that, obviously this is controlling speed of compressor and literally adjusting our RPM. This is adjusting how our diffusion gap functions. It's changing the characteristics on a fundamental level for just how the refrigerant's going to flow through there. So in terms of, let's come back to the question. So how do you explain the difference between VGD and VSD operation in a part load condition? So part of what we can do is, with the VSD first, we're going to slow the compressor down as much as we can. Now we still have a surge curve to worry about. So on that surge curve, we have our graph, we've got our surge line, we've got our choke line, we're somewhere in here. And then as we slow down the drive, we are pushing over, because this would be our flow volume and this would be our lift value. Okay, so this is how much lift we have across this impeller. So this would be pressure 1 on lift, pressure 2. The difference here is your lift. Okay, so we're reducing flow, but by reducing this flow, we end up pushing closer to that surge line, especially if that process, we're not reducing the lift on the machine, which can happen. We can have situations where, because of our water temperatures and such, we're not actually reducing the lift in the process, but we are just strictly reducing flow. So in that event, we're just slowing down, okay? And by slowing down, this flow's turned down, and eventually we could push into kind of a surge condition. Where this VGD, part of what it does is the best way I could try to describe it on this graph would be, it can adjust how much lift we can handle. Okay, so just imagine that with this VGD, by using it, we're going to be able to handle a higher lift without going into a stall or a surge condition. Now, the other thing to that is we do reduce flow. So part of that VGD is it does cut down on how much flow is able to go through that diffusion gap, because it does become a physical block. And so our little gap here that we can flow through in the diffuser does become smaller. Like, that is part of that process. And that is why some of these chillers, they do not have a inlet guide vane, an IGV. They only have a VGD with a drive. And part of that VGD's process is, as that chiller is unloading, we push the VGD to a closed position, which narrows our diffuser gap, reducing how much flow goes through there. Once the VSD or the VFD has hit its minimum frequency that it's going to be able to run at that time. So once it's as slow as it can go, we can use a VGD to also reduce load even further. So your a YMC squared or a YZ for sure works like that. Those do not have an IGV. Yes, and your YMC squareds are also this way. So those are magnetic bearing machines, but those are two examples of where we don't have variable guide vanes coming into the compressor. We just have a VGD and a VSD in order to modulate flow. So they're in part load conditions. It just kind of depends on what they're going to do. If I'm going to approach this from, say, a York perspective, then the VSD is going to be the primary, or let me take a step back actually. From startup, your chiller will come online with your VSD in a minimum speed first. Okay, so it's going to be at minimum hertz, and your VGD should be in a full closed state. It's pushed all the way out. Once the chiller is ready to load up, this is just your sequence of operation. Once we're loading up, then the VGD will open. It will go as open as it can, and if that means it's able to go to completely open, then that's awesome. Then, once this is fully open, our VSD will begin to increase speed, which increases our flow. This whole process is the staging up sequence. So we will stage up as far as we need to. That reverse process is true when we need to stage down. So this will stay open as much as it can, and we will slow the drive down to a minimum speed. Then once we hit that speed, which will be based off of this chart here, the next step will be to open or to start closing the VGD. Where this gets really convoluted, if we are trying to unload, but we're having lift issues, and the chiller is pushing the surge boundary, which a York machine like these will have a stall detector that is monitoring for when we're pushing into a surge condition. This VGD will still function like it would on any other machine, where it's not even trying to control capacity. It's trying to prevent the surge in the stall condition. So in the event that we're running at a part load, but we're not trying to fully unload, the VSD is still the primary load and unload mechanism, meaning speeding up or slowing down the compressor is still the main way we're controlling load. And the VGD at that point, its main job is to prevent the surge and stall condition by modulating this diffusion gap. But once the compressor actually hits its minimum reference speed that it can get to, then the compressor will intentionally use this VGD, not just for surge protection, but also for load and for unloading the compressor further by restricting this diffuser gap and allowing less total volume through. So it serves a dual function at that point with what it's doing. So yeah, hopefully that helps kind of clear that up a little bit. I want to make sure I got that fully. Explain the difference between VGD operation. VSD has it released to part load. Yeah, I think that pretty well covers that. Yeah. Let's see here. Hi, Holden. I am a light commercial side. Thinking of learning centrifugal. South of East Michigan. Would you seek a union or non-union company to work for? You know, that depends. And that's a hard question for me to answer. So it depends on your market there, Christian. So in some markets, we have really good unions, right? I personally am a non-union, okay? So I need to give this disclaimer right up front. I've never been a part of the union, but I see where they have had and have a purpose. And I also recognize that there are some really good unions and there are some that are not as good. So I've been in a position to where I've had to kind of experience more of the not as good union side, I would say. And in most cases, not all. Anyway, you've really got to fill out your market and maybe talk to some local guys who are or are not part of the union. The trouble here is you get into this culture issue where some of us who are we're hardcore, I'm not going to do the union thing. And some of us who are a part of the union, they become hardcore union or nothing. And there's really strong arguments to both ways, in my opinion. I know that I personally wouldn't serve in a local union to me, and I never did, obviously. But I could also see where if I was in a different region, that would be a different case. And an example I'll give here, I've heard that some of the unions in California are actually pretty decent, and they do a really good job of training, educating. There's a lot of good stuff happening there, and that's I don't know the ins and outs of the unions, but I think some of their like higher up side of things are kind of based out of that region. And I've also worked in the Northeast with crews, and they're very happy with their unions. They've got some really really good unions out that direction. So I think it really just it depends, and it's going to be really hard to get that answer. Um, a better way to say this is if you are in a union dominated state, it's probably worth considering the union route, because that's where a lot of the opportunity may be compared to going the non-union side. But there again, you can make a strong argument that not everybody wants to work with the union, and there's going to be less people going the non-union path, so maybe you could find a better way there. Do you see what kind of there's this very tit for tat dilemma you fall into, and the reasons why you should or shouldn't. I do find that unions pay higher scale early on in your career, but I haven't found that they do that over the long term. And it's not, no, don't get me wrong, unions and non-union salaries definitely compete, but they compete later in your career. And I would even venture to say in my local region, we've been in a position to where you can actually push those boundaries a little further in the non-union side than you can in the union. But for sure, without a doubt, the union companies I have seen will for sure pay higher wages on an entry level side, but there is a slower growth process and metric that I've seen personally. And you could argue that really heavily. I'm kind of dancing around this because there's just not I don't feel confident having a clear, distinct, this is the right way to go, because I don't think there is one. And just because I haven't gone union doesn't mean that you're not in a position where you shouldn't. I want to be very specific with that. Yeah. Hopefully that helps in some kind of way. I know it's not the most clear answer in the world. I'm sorry. Disadvantages of eddy current test. Cost. So doing it a bunch cost a lot. I mean, it costs a lot to do it the first time. I mean, and it's a lot of time, it's a lot of labor. So if you're doing it more than once a year, which would mean you would be brushing your tubes more than once a year, I would say that puts extra stress on the tubes, having a brush put through them more often. Right, so you could argue that as another disadvantage. I feel like those are probably the main ones. Extra wear and tear from additional brushing, and then the cost requirements to do an eddy current that often. Do you have any experience on thread sealants for glycol filled lines? Metal to plastic and plastic to plastic. Yeah, in terms of those thread sealants, the only excuse me, I personally have just used standard pipe dope and Teflon tapes. Like the Blue Monster specifically is one of my preferreds. Trying to think if I don't remember having any major problems with it, like leaking or not holding up long term. Yeah, I would say that me personally, that's I've gotten away with it, right? Like I said, Blue Monster specifically, one of my preferreds by far. using something like that is what I've done. That may not be correct and whatnot. We don't have a huge amount of glycol. Like we definitely have glycol in this region, but we don't have a ton of it. So I have, call it limited exposure compared to most other things. And you don't have to go very far north from where I'm at, and you get far deeper into glycol systems than I've had to personally deal with in terms of having to make your decision which is the best sealant. So to that, let's follow up a question. Have you tried something like the Blue Monster Teflon tape or anything like that, and has that, are you having issues where that's not holding up to the glycol? And then to build on that, which glycol are you commonly using the most, propylene or ethylene? Because let's see, ethylene is the toxic one, so I would be curious if one reacts more negatively with the sealants than the other does, because most prefer the propylene, just due to it's not toxic, but it's less efficient anyway. Yeah, I'd be curious to know, what have you tried in terms of sealants? And this may be a fun chat we can get into. I got about 10 minutes left. I do have time for at least one more question if somebody has one. And let's see, what else do I have over here? So next one I had, how can I freeze chiller if a hold? I don't understand. Okay, I think I see where that's. Sorry, I'm reading some of the backlog questions I've had in the queue. In the meantime, what type of chillers are likely to have falling film? Let's get into this one. Okay. How can I freeze chiller if it hold 800 pounds already and standing pressure is 50 plus psi? I'm not messing with chillers usually and don't understand what can cause freeze evaporator with 800 pounds already charged. Well, we don't know the refrigerant type you're dealing with, but being that you've got 800 pounds and you're at over 50 psi, I'm going to assume it's probably 134 maybe. Either way, the key here is your saturation temperature. We need the saturation temperature to be above freezing, period. So whatever refrigerant you're using, it doesn't matter. And with 800 pounds in the system, again, that if you're asking this question, you're probably working on a smaller system to begin with, and that's okay. My point there being, on a larger centrifugal, 800 pounds is just a portion of the charge. It's not that much compared to the total charge when we get into thousands and thousands of pounds of refrigerant that these things are going to hold. So either way, with your standing pressure, if that is above your freezing saturation, then you're fine, because the point there is if your saturation is below freezing, then when liquid refrigerant specifically makes contact with the tubes with water in them, then that liquid refrigerant can draw enough heat out of the tubes to freeze the water if we're below freezing temperatures. Now, if our saturation, despite the refrigerant, if our saturation is above a freezing temperature, then once that liquid refrigerant makes contact with the tube, we're not going to drop it down below freezing to begin with. So we're not going to freeze that water, period. And that is the main concern. That is the main concept that we're having to think about and work around, is what is the freezing saturation pressure, and let's get above that. And this is where you could charge vapor. So I've talked about this a lot recently, where if you pre-charge vapor into the chiller and get that pressure up, then charging liquid from there is far less of a risk versus if you tried to just send straight liquid in right out the gate after your evacuation, and then you end up causing the liquid refrigerant to make contact with the water. So if you're flowing water, like, there's still ways of mitigating that risk and that problem. Flowing water would be one of them. And either way you go with it, is still recommended to flow water, whether you pre-charge vapor or not. But that is the key there, is the saturation temperature. If you're above that, the volume of refrigerant does not matter. Okay? You can get into systems where 800 pounds, that's just a portion of it. Now, in our context, that's probably the majority of your charge, I would assume, if not your entire charge. So, yeah, that's the key takeaway here. Saturation, 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 saturation. I'm just driving that home. All right. We had a project that the dope on Teflon we used got pushed out of the threads after a couple of days. We used mainly propylene, switched to PTFE filled dope, and it's worked much better. Okay. Interesting. A tech support rep suggests an aerobotic thread sealant. But I've never seen one before. But it looks like Loctite makes one. I'd be very curious to see the results on that. And if that would be a fun follow-up we could do, because if you've had good results with it and you like it, maybe that'd be a good recommendation we can bring back and throw into the stream and a video or live. Like, we could do some stuff with that, because I mean, you're not going to be the only one dealing with that problem. So if you're facing that, again, that's not an issue I've had to deal with as much. So yeah, if you're having that problem, other people are having that problem, and we're all having to work through that same issue at some point in our career cycle, right? So if we can get a good solution to that and get that out there, I think that'd be really, really great. Or if y'all just wanted to do it on your side, not saying I have to be involved, but I think that would be a really good help for a lot of young technicians who are trying to figure this stuff out. Anyway, I really appreciate everybody's time. Like I said, I do have to jump off here, and we've got some appointments out of town. We've got to go stay out overnight for the new baby boy. But yeah, we're back into it. So I do plan to come back next week. I will be at fire school the week after that. So we're going to Texas A&M, and I've got this behemoth. Oh, wrong one. This behemoth. This is the fire book they hand you, and they tell you to go through. So this gets you through firefighter certification 1 and 2. Now, I won't be going through the full certification. I'm just taking certain classes because I'm just doing volunteer work. So I'm not trying to become a paid firefighter or anything. But my point being, that will be in 2 weeks. Yeah, so there won't be a stream on the 21st, but there will be on the 14th, and then I'll pick it back up on the 28th. And then from there, I plan to have a normal schedule, just like we had prior to my life getting very interesting suddenly. So, yeah, that's the plan. I really appreciate everybody. love to work with you over at chilleracademy.com. I hope you're enjoying the emails I'm sending out through the, I guess call it a newsletter, if you will. It's what everybody else calls them. And if you are interested in getting in that, just you can either reach out to me or just signing up to the the free service course on at chilleracademy.com. That'll automatically enter you into that that newsletter. Or if you don't want to go through that process, you can just send me your email. I can add you to the newsletter list from there, and then you can start getting those bi-weekly or twice a week, not bi-weekly, there's twice a week newsletters where I send something out, talk to you, whatnot. Anyway, y'all have a great week. I will see y'all next week. Really appreciate it.